Hello students, it's Mr. Win here. Thanks for joining me. Today we're going to be working on solving absolute value inequalities and graph the solutions. Okay, so there are two different IXL practices that I'm going to show you. The first one we'll just do a couple of problems because the next one is the one that actually has all the good problems. So let's take a look at these really quick. I'm just gonna show you first how they are solved really quick. Um, and my internet is very slow. Oh, there it is. Okay, so let me open up my not that my web paint. Okay. All right, here we have a pretty easy equation here. We have absolute value of c minus 6 less than or equal to 3. Now, before you even try to solve this, make sure your absolute value is isolated. So we're going to move the negative 6 away. We're going to end up with c, absolute value of c is less than or equal to 3 plus 6. So what's 3 plus 6? That is 9, right? 3 plus 6 is 9. So we have 9 here. Okay, so whenever you have an absolute value that is less than or equal to, we call this the conjunction um, inequality, or this is better known as the end case. The end case, okay? So our solution is going to be graphed in between, right? So this is what I mean right here. This is called the conjunction case, and this is called the disjunction case, right? The end, this is the end case. All right, and this is the or case, okay? The end case is when the absolute value is less than some number, and the or case is when the absolute value is greater than some number. So we're gonna see them later. All right, so this one, we split it into two cases, okay? The first case is normal. C is less than or equal to negative 9. I mean, positive 9. The case 2 is where you have to remember if your absolute value happened to be negative, then the absolute value, the inequality actually switch. Okay, so instead of saying c is less than negative 9, which would be false, we will have to say c is actually greater than negative 9, right? So remember to switch your inequality in case 2. Okay, case 2 is the negative case. So switch the inequality. So there are my solutions. So because this is an and case, I am going to write them together. So I'm going to write them like this. I'm going to put negative 9 first because that's the smaller value. I'm going from left to right, right? And then I'm going to do less than or equal to, right? Or actually greater than or equal to, but C is over, C is in the middle. So I'm going to write it that way. And then one more, and then positive 9, right? So what this is saying is, C is actually less than 9, which is this part right here, okay? And then this part right here says C is greater than 9, which is actually this part right here. So because it is a conjunction, we write them together as one compound inequality, okay? So, I mean, if you were to solve this naturally on paper, you would put the word and here, and you would call it a day. You'll be done, right? But if you were to express your solution as a compound inequality, you must write it like that, okay? Let me clear up all my mess here. Submit my answer. I think this is correct. Yes. Hi, this one's an easy one. Let me jump level really quick. Let's say this one. Okay, we got a minus there. We got a minus absolute value. So I naturally just move it away just to make it positive. And if it goes over here, it becomes plus absolute value of r, right? That means the negative 5 needs to go. The negative 5 needs to go back over here, and it will become positive 5. So it become plus 5, okay? Plus 5. Ooh, I was going to put 4. Plus 5. Well, 4 plus 5 is 9, and that is greater than or equal to absolute value of r. Now, if I were to read this, r would be less than, right? R would be less than or equal to 9. Again, when we have a less than case, we actually have a conjunction, okay? And I don't know if there's an easy way to remember this, except just to, I guess, memorize it. Or when you actually solve this, it would make sense when you put it on the graph. So until you see the graph, this does not make sense. The conjunction and the disjunction does not make sense. At least I don't know how to explain it. But when you see the graph, you understand it a lot better. So when the absolute value is less than something, okay. So here are two cases. The first case is natural. R is less than or equal to 9. Okay, and then the second case is R is greater than or equal to -9. Okay, so I gotta switch my inequality symbol when I have a when I have a negative case. So I know we're not graphing here, but let me just represent these on a number line to let you see. So here's 9, and here's the -9 to the left of that, right? And 0, it's somewhere in between. 0, it's somewhere in here, right? In the middle of that. So when I solve this, it says R is less than 9, which means that I have to go from 9 here, and I have to go back this way, right? I have to graph I have to shade my solution back this way, all the way here. But then when I get to -9, it says R is greater than that, so I have to go from here, and I got to go back up. Do you see how the solutions kind of overlap right here in the middle? That's why this is a case of a conjunction. Conjunction means you joining the solutions together. So that's what I meant when I say it makes more sense when you see the solutions on the graph, right? So we're going to write this with R in the middle, 9 to the right, and -9 to the left with the inequality symbol like that, okay? That's how we're going to write it, okay? So we're going to go here, put -9 here, put that symbol, and then the R, and then that symbol again, and then the +9. Submit. Ta-da. Okay, we're gonna. This one kind of complicated. I'll work this one out, and then I'll jump level. Okay, so let's see. We got to clean up everything around the absolute value. But the first thing I want to do is I want to make sure this negative term is actually positive. So I'm going to move that over here. So it'll become positive 2 times the absolute value of 9p. Now, I hope you guys understand that why I can move the whole thing like that. The whole thing can be moved because it's considered one term, right? I can move one term at a time. So that's considered one term. That means I can move all of it at the same time. And then the negative 1 is going to go back over here to be +1, right? So if I were to simplify this, I would have 4 greater than or equal to, I'm keeping the symbol the same right now, absolute value, actually 2 times the absolute value of 9p. All right. And then I have to clean up the absolute value. That means I have to move the 2 away by dividing it. So I'm going to divide it on the other side. I get 2 is greater than or equal to absolute value of 9p. Okay, so now that your absolute value is separated, you can actually put it into two cases. Okay, so 2 equals, you can switch them around if you want, but you don't have to. You can solve it this way. It's 2 is greater than or equal to 9p. Or you can say that 9p is less than or equal to 2. Okay, either way is fine. And then p is, you're going to divide by 9. So p is less than 2 over 9. Okay, 2 over 9 is a not very nice fraction. So I'm going to just keep it, well, not a nice number. So I'm going to keep it as a fraction so that it looks nice. Here, I got to remember to switch my inequality and change the sign. Change the sign, switch my inequality. Okay, so change the sign on the constant itself, right? Not on the absolute value. So I'm going to have 9p, no more absolute. Okay, and then same thing, I'm going to divide both sides by 9. Oh, if I divide by 9, I shouldn't have a 9 here anymore. I should have p alone. And over here, I would have -2 over 9. Now, this is a case where it's greater than. right? This is a greater than case, so we're going to have what we call a disjunction, okay? And yes, I mean, without a graph, you're just going to have to memorize that, okay? If it's greater than, it's disjunction. That means I'm going to be writing my solution this way. And it will make more sense when I put it on the graph. So let's take a look at this on the graph. So here is -2/9, okay, somewhere on the number line. And of course, the +2/9 is to the right of that, right? So +2/9 is over here somewhere, and 0 is in between, right? Now, this solution says that P is less than or equal to that. Oh, it's actually, oh, this is a greater than. Oh, when I move the P is actually a less than. I'm sorry, guys. I apologize. See, when I put it on the graph, I realized that this is actually a conjunction case because I did move my absolute value over here. And when I move my absolute value over here, it actually become less than, right? Whenever the absolute value is less than, it's a conjunction case, okay? So if you are still confused about conjunction and disjunction, once you try to put the solutions on the graph, you will see. So like right here, it says P is less than 9. So I'm actually going to start from here and I'm going to graph this way, right? So far you already see that it's going to overlap. When I graph this one, P is greater than -2/9. So this is a conjunction, right? So I will be writing my solution this way right here, together. So I'm going to do a fraction. And remember, negative number needs to go on the right. So I'm going to do negative and then a fraction 2/9. And I'm going to use this symbol. Oops, make sure you get out of that function, the fraction first. Do the symbol, type in P, do the symbol again, and do another fraction for 2/9. Okay, sometimes typing the solutions in is more trouble than actually solving it. So as long as you can solve these correctly, you should feel good about it. Okay, submit. Sorry, that's the bell. Clear. I hope no announcement and no disruption today, but oh well. Let's jump level. It's still pretty easy. Let's jump one more. All right, next one. This one is not too bad at all. This one is actually an easy case. Let's jump level. Well, okay, this one is not too bad. The numbers is just bigger. Okay, so let's do this. The absolute value is already been cleaned up, right? That means everything around it has already been cleared away. So we're ready to split it into two cases. So the first case is the normal case. 225 is greater than 9R plus 225. Okay. So in this case, I just subtract 225 away, okay, to move it over here, right? I end up with 0 is greater than 9R. So when I divide both sides by 9, I get R is less than 0, okay? Less than 0. Now, notice the absolute value is less than, so this is a conjunction case, conjunction, okay? Conjunction case, conjunction. Conjunction is when you graph the solutions together in the center, in between, okay? This is known as the end case. Okay, let's do case 2. Case 2 is the negative case, -225, and we have to switch the inequality. So instead of going this way, it's going to go this way, and then 9R plus 225, 225. Okay, so I'm gonna be subtracting 225. Oh, that means I get my value is really large, right? The negative is really large, and then 9R is greater than that. So it's greater than 450, right? 450. And if I divide by 9, I would get oops, I divided by 9, 9 would not be there anymore. I have made that mistake before. R is greater than, okay, 9 goes into 45 5 times, so it's going to be -50, okay? -50 is my solution. So R is greater than -50, so I'm going to start at -50. And this is a conjunction. That means it's going to be graphed somewhere in the middle. So start with the little one, and then go this way, go up this way because it's greater than. And where do I stop? I stop at 0. Okay, so from -50 up to 0, that's where all my solutions live. This is a conjunction case. Okay, this is an AND case. And if I were to write this as an um, inequality, it would start with -50, and oops, and it will have this symbol, and then it will have the variable, and then it will have the 0 to indicate that R lives in between these two numbers. Okay, and one thing I have to remember here is that I do have an equal sign. I forgot to put it in my inequality. I do have an equal sign in the original problem, so all of my value is it has an equal sign to it, right? So I forgot that part. However, I didn't forget it on my graph. My graph is supposed to have a solid dot, right? A closed dot or a closed circle. Okay, so our graph is correct. I just forgot to put it on my problem. So submit. Ta-da. Okay. This one, pretty easy. Jump level. All right, we're in the challenge zone. Let's see here. I will do a couple and then we'll call it a day. Okay. To clean this, a few things. Let's get rid of this 4 first. That means I'm going to divide this by 4, okay? And then I would get 2, right? So here's my semi cleanup equation. 2 is greater than the absolute value of -2v minus 10. Okay. Now, if you see, whenever you see a negative in here, you know you have to factor that out. So you're going to factor that right hand side out. So you're going to pull out a -2 absolute value. Okay. That's right, like that. And then inside of that, you're going to have v left plus, okay, it's plus because negative times positive becomes negative, which is what we have originally. And then 5, because I factor out a 2 out of 10. So I take 2 out of 10, I have 5 times left. Okay, so this 2 actually become positive. So I'm going to divide everything by 2, not -2. I divide everything by 2, okay? Because this is actually a positive value. Absolute value of -2 is +2. So that's going to cancel that, and I have 1 left. Greater than absolute value of v plus 1. Plus 5. Now I'm ready to split into 2 cases. So case number 1, I'm going to do this right here. Case number 1, 1 greater than v plus 5. I'm going to subtract 5. So that's going to be v less than -4. That's one of my solutions, okay? Well, one set of my solutions. So that's case 1. Case 2 is going to be not 1, but -1. It's the negative case. And not greater than, but less than. So I got to switch the inequality. And then v plus 5. No more absolute value, okay? And again, I subtract 5. But this time I won't get a -4. I get a -6. And then v is going to be greater than that. So you got to read from the letter first. V greater than -6, and then v less than -4. So -6 is here, -4 is here. And look, if you are greater than -6, you're going this way. If you are less than -4, you're going this way. So this turned out to be a conjunction problem, right? This is a conjunction, not a disjunction. That means I'm graphing the solutions together. And I do have an open circle, an open dot. I don't have an equal sign, so it's going to be open, not closed, okay? So I'm going to clear those little things there. Actually, no, I'm going to graph it on top of it just to let you see. So if you click it once, it's closed circles, like, okay? You click it again, it's open. So I want open. So now I click it once, I click it again to get it open, okay? Make sure you check your graph carefully before you hit submit, because one tiny little mistake, it's going to count it wrong, and then it knocked you back like 10 points, right? So just check your graph carefully before you hit submit. Awesome. I'm going to do one more. Okay. One more. Let's see here. First, we're going to clean the -1 away, +1. Then we're going to divide by 6. Okay. So let's add 1 first and then divide by 6. Well, 260, I'm going to do this on a calculator. 269 plus 1 is 270. And then 270 divided by 6 would be 45. So on the left-hand side of my inequality, I have 45. You see how much nicer that is? Just to clean it up and simplify your inequality. Less than or equal to, the 6 is gone, the -1 is gone. All I have left is the -9r minus 315 on the inside. Now, you would wonder, well, can I factor out a 9? Can I factor out a 3? Can I factor out anything? Well, the most important part to remember really is to factor out a negative, okay? That negative cannot be your leading coefficient, okay? This negative cannot lead the variable on the inside of your absolute value. So whether you can factor out a 9 or a 3, it's really not as important as factoring out the negative, okay? So even if I don't factor out a 9 or a 3, but I factor out a negative, it's still going to make my inequality a -1, my inequality very nice to work with, right? So I factor out a -1. Inside, I have 9r plus 315. So you see, it's all nice and clean inside. It's positive leading the coefficient, right? And this 1 turned out to be +1. And if it's +1, I really don't need to worry about it too much, right? Because if I divide it by a +1, I still get 45 over here, right? So my inequality becomes 45 less than or equal to absolute value of 9r plus 315. And then now I can split it into 2 cases, okay? So let's do it right here. I'm going to draw a line there. We'll do case 1 on top, okay? Case 1. Case 1 is going to be the normal case, 45 is less than or equal to 9r plus 315. Subtract 315 and then divide it by 9. So my r is what? Let me do this on a calculator, right? Because I'm going to subtract the 315 and then eventually I would divide by 9, right? So you can do both steps on your calculator. You're going to start with 45. You're going to take away 315. Oh, sorry. Don't need that 0. Enter. And then divide it by 9. And then you get -30. So r is greater than or equal to -30. That's one of your solutions, or one solution set. Case 2. Case 2 is when you have a -45, right? -45. So and then you have to remember to switch your inequality, right? And then 9r plus 315. Okay? Um, Now, subtract 315, the operation is exactly the same. My solution is going to be r is less than instead of r is greater than, right? So I'm going to do it on the calculator. Instead of 45, I'm going to start with -45 because that's my negative case, minus 315. Oops. It's the same operation, 315. And then enter and then divided by 9. And my solution is -40. Okay, so I'm going to go over here and I'm going to try to graph this. So I'm going to start at -40, which is down here, a closed circle, okay, and it's less than that. So it's going to travel this way. And then I'm going to start at -30, and it's greater than that, so I'm going to travel that way, okay? So this is a disjunction case. I'm going to hit submit. All right. So it's correct. Thank you guys for joining me. You guys can try to get more questions done. Don't forget to subscribe to my channel and send me any questions you have. Thank you so much for watching. Bye bye.